Question 1. The performance metrics show a high incidence of musculoskeletal complaints among assembly line workers. As a certified ergonomics professional, CEP, which of the following approaches would be most appropriate for quantitatively assessing the ergonomic risks associated with their tasks, adhering strictly to U.S. regulatory frameworks and professional ethical standards? Option A. Measure the average metabolic rate of workers during their shifts to assess overall physical demand, without specifically analyzing posture or force exertion. Option B. Rely primarily on worker surveys to gauge perceived exertion and discomfort levels, using this subjective data to inform recommendations. Option C. Utilize a force gauge to measure peak forces during lifting tasks, without first verifying the gauge's calibration or its suitability for the specific types of loads handled. Option D. Conduct a detailed posture analysis, using a validated observational method to quantify joint angles and movement patterns during typical work cycles, comparing findings against established ergonomic exposure limits. The correct answer is D. Conduct a detailed posture analysis using a validated observational method to quantify joint angles and movement patterns during typical work cycles, comparing findings against established ergonomic exposure limits. Explanation. This scenario presents a common challenge for certified ergonomics professionals, CEP, where the interpretation and application of quantitative assessment data must align with established regulatory frameworks and ethical practice. The professional challenge lies in selecting the most appropriate and defensible method for evaluating workplace risk, ensuring that the chosen tool not only provides accurate data, but also meets the requirements for documentation and intervention planning as mandated by relevant regulations. The CEP must demonstrate a thorough understanding of the limitations and strengths of various quantitative tools and their applicability within the specific operational context. The correct approach involves utilizing a recognized and validated posture analysis tool that provides objective, quantifiable data on joint angles and movement patterns, such as those derived from observational methods or motion capture systems, and then comparing these findings against established ergonomic exposure limits or guidelines. This approach is correct because it directly addresses the biomechanical risk factors associated with posture, a key determinant of musculoskeletal injury. Regulatory frameworks, such as those enforced by OSHA in the U.S., emphasize the need for employers to identify and control workplace hazards, including those arising from awkward postures. Using a validated posture analysis tool allows for a systematic and repeatable assessment, providing the objective evidence required to justify interventions and demonstrate compliance with general duty clauses and specific standards related to manual handling and workstation design. Ethical practice dictates that the CEP should employ methods that are scientifically sound and contribute to the well-being of the worker. An incorrect approach would be to rely solely on subjective worker self-reports of discomfort without corroborating objective data from a quantitative assessment tool. This is ethically problematic, as it places undue weight on subjective experience without a systematic evaluation of the physical demands of the task, potentially leading to misdiagnosis of the root cause of discomfort or injury. It also fails to meet regulatory expectations for hazard identification and control, which require objective evidence of risk. Another incorrect approach would be to use a force measurement tool that is not calibrated or validated for the specific tasks being assessed. This would yield unreliable data, undermining the credibility of the assessment and potentially leading to inappropriate or ineffective interventions. Regulatory compliance requires that measurement tools be accurate and appropriate for their intended use. Finally, an incorrect approach would be to focus exclusively on metabolic rate measurement, without considering the biomechanical aspects of the task. While metabolic rate is important for assessing the overall physical exertion and energy expenditure, it does not directly quantify the risks associated with prolonged static postures or forceful exertions, which are primary concerns in many ergonomic assessments. This approach would fail to address the specific biomechanical hazards that posture and force analysis are designed to identify and control, thus not fully meeting the requirements for a comprehensive ergonomic risk assessment. Professionals should approach such situations by first understanding the specific regulatory requirements applicable to the workplace and the nature of the tasks being evaluated. This involves identifying the primary risk factors, e.g., posture, force, repetition, vibration, and then selecting the most appropriate quantitative assessment tools that are validated, reliable, and capable of providing objective data relevant to those risk factors. The data collected should then be interpreted in the context of established ergonomic guidelines and standards to inform recommendations for risk reduction and to demonstrate compliance. Question 2. System analysis indicates that a manufacturing assembly line worker frequently performs a task requiring them to reach overhead and twist their torso to grasp components, resulting in sustained shoulder abduction and external rotation, and lumbar rotation beyond neutral postures. The worker reports occasional shoulder and lower back discomfort. As a certified ergonomics professional, CEP, what is the most appropriate course of action to address the potential for joint injury? Option A. Document the worker's reported discomfort and inform them that such movements are inherent to the task and that they should focus on improving their personal conditioning. Option B. Advise the worker to perform stretching exercises before and after their shift to improve flexibility and reduce muscle strain around the shoulder and lumbar spine. Option C. Conduct a detailed biomechanical analysis of the overhead reaching and twisting motions, quantifying joint angles, repetition, and force, and recommend workstation modifications or tool redesign to reduce extreme joint postures and minimize the need for forceful twisting. Option D. Recommend the use of a general-purpose brace for the shoulder and lower back to provide support during the task. The correct answer is C. Conduct a detailed biomechanical analysis of the overhead reaching and twisting motions, quantifying joint angles, repetition, and force, and recommend workstation modifications or tool redesign to reduce extreme joint postures and minimize the need for forceful twisting. Explanation. This scenario presents a professional challenge because it requires an ergonomics professional to balance the need for efficient task completion with the imperative to protect worker health and safety, specifically concerning joint health. The core of the challenge lies in accurately assessing the risk associated with repetitive, forceful movements that exceed optimal joint ranges of motion, and then recommending appropriate interventions. The Certified Ergonomics Professional (CEP) designation implies adherence to a specific ethical and regulatory framework, which in the absence of a specified jurisdiction is assumed to align with general best practices in occupational ergonomics, often influenced by standards like those from the Occupational Safety and Health Administration, OSHA in the U.S., or similar bodies globally, which prioritize hazard identification and control. Correct approach involves a comprehensive ergonomic assessment that meticulously documents the specific joint movements, their frequency, duration, and the forces involved. This assessment must then be used to identify movements that push joints beyond their neutral or safe ranges of motion, thereby increasing the risk of musculoskeletal disorders, MSD. The professional's responsibility, guided by ethical principles and regulatory expectations, e.g., OSHA General Duty Clause requiring employers to provide a workplace free from recognized hazards, is to recommend specific, evidence-based interventions. These interventions should aim to reduce the risk by modifying the task, the workstation, or providing appropriate tools and training to keep joint movements within safe parameters and minimize static loading. This aligns with the proactive hazard control hierarchy, prioritizing elimination or substitution of hazards. An incorrect approach would be to dismiss the observed joint movements as simply part of the job without a thorough risk assessment. This fails to acknowledge the potential for cumulative trauma and the employer's responsibility to mitigate recognized hazards, violating the ethical duty to protect worker well-being and potentially contravening regulatory requirements to address workplace risks. Another incorrect approach is to focus solely on the worker's perceived discomfort without objectively measuring the biomechanical stressors. While subjective feedback is valuable, it must be corroborated by objective ergonomic data to accurately identify the root cause of potential injury and to justify interventions. This overlooks the scientific basis of ergonomics and the need for data-driven recommendations. Finally, recommending generic solutions without a specific analysis of the joint kinematics and forces involved is also professionally unsound. Effective ergonomic interventions are tailored to the specific tasks and postures, and a generalized recommendation may not adequately address the identified risks, leading to ineffective controls and continued exposure to hazards. The professional decision-making process for similar situations should involve a systematic approach. 1. Identify the task and the workers involved. 2. Observe the work activities, paying close attention to postures, movements, and forces applied by the joints. 3. Objectively measure key ergonomic risk factors, including joint angles, repetition rates, and force exertion. 4. Analyze the collected data to determine if joint movements are consistently exceeding safe ranges or involving excessive force, thereby posing a risk of MSDs. 5. Consult relevant ergonomic guidelines and research to establish acceptable limits for joint motion and force. 6. Develop and recommend specific, prioritized interventions based on the hierarchy of controls, focusing on eliminating or reducing the identified risks. 7. Document the assessment, recommendations, and any follow-up actions. Question 3. Benchmark analysis indicates a significant increase in reported musculoskeletal discomfort among assembly line workers performing a repetitive task involving moderate force and awkward postures. The production manager is concerned about potential impacts on output and is requesting immediate, actionable solutions. As a certified ergonomics professional, CEP, which approach best addresses the underlying tissue tolerance and injury mechanisms while considering stakeholder needs. Option A. Immediately implement a mandatory stretching program for all assembly line workers, assuming that increased flexibility will alleviate discomfort and prevent injuries. Option B. Conduct a detailed biomechanical analysis of the task, including force, repetition, and posture measurements, and gather subjective feedback from affected workers to identify specific risk factors and their correlation with known injury mechanisms, then propose targeted interventions based on this data. Option C. Advise the production manager to temporarily reduce production quotas until the discomfort subsides, without conducting a detailed assessment of the task itself. Option D. Rely solely on employee self-reported pain levels to identify the most affected individuals and suggest they take more frequent breaks. The correct answer is B. Conduct a detailed biomechanical analysis of the task, including force, repetition, and posture measurements, and gather subjective feedback from affected workers to identify specific risk factors and their correlation with known injury mechanisms, then propose targeted interventions based on this data. Explanation. This scenario is professionally challenging because it requires the certified ergonomics professional CEP to balance the immediate needs of a production-focused stakeholder with the long-term health and safety of employees, grounded in established scientific principles of tissue tolerance and injury mechanisms. The pressure to maintain output can lead to overlooking or downplaying early signs of musculoskeletal discomfort, which, if unaddressed, can escalate into serious injuries. CEP must navigate this by advocating for evidence-based interventions that protect workers without necessarily halting production entirely, demonstrating a nuanced understanding of both human factors and business objectives. The correct approach involves a thorough, multifaceted assessment that prioritizes understanding the underlying biomechanical and physiological factors contributing to potential injury. This includes direct observation of tasks, measurement of exposure variables, force, repetition, posture, and importantly, gathering subjective feedback from affected employees regarding their symptoms and perceptions of risk. This data is then synthesized to identify specific risk factors and their relationship to known tissue tolerance limits and injury mechanisms. CEP's role is to translate this scientific understanding into actionable recommendations that mitigate risk, such as job rotation, task modification, or provision of appropriate tools and equipment, all while communicating the rationale clearly to stakeholders. This aligns with the ethical imperative of the CEP to protect worker well-being and adhere to professional standards that emphasize prevention and risk reduction based on scientific evidence. An incorrect approach would be to solely rely on employee self-reporting without objective biomechanical assessment. While employee feedback is crucial, it may not always capture the full picture of biomechanical stressors or may be influenced by factors other than ergonomic risk. Without objective data, the CEP cannot definitively link symptoms to specific task demands or confidently recommend targeted interventions, potentially leading to ineffective solutions or missed opportunities for prevention. This fails to meet the professional standard of evidence-based practice. Another incorrect approach is to focus exclusively on the frequency of reported discomfort without investigating the underlying causes. While a high frequency of complaints signals a problem, it doesn't provide the diagnostic information needed to address the root cause. This approach risks implementing superficial solutions that do not address the biomechanical or physiological stressors, leading to continued risk and potential for injury. It neglects the critical step of understanding the specific mechanisms of injury. A third incorrect approach would be to implement generic, one-size-fits-all solutions without a specific assessment of the tasks and employees involved. This often stems from a desire for quick fixes, but fails to account for the unique biomechanical demands of different jobs and the individual variability in tissue tolerance. Such an approach is unlikely to be effective in preventing injuries and may even introduce new risks or be perceived as dismissive by employees. It bypasses the essential diagnostic phase of ergonomic assessment. The professional decision-making process for similar situations should involve a systematic approach. 1. Define the problem by gathering initial information and identifying stakeholders. 2. Conduct a comprehensive ergonomic assessment, integrating subjective and objective data. 3. Analyze the data to identify risk factors and their relationship to tissue tolerance and injury mechanisms. 4. Develop evidence-based recommendations tailored to the specific situation. 5. Communicate findings and recommendations clearly and persuasively to stakeholders, emphasizing the rationale and potential benefits. 6. Implement and evaluate the effectiveness of intervention, making adjustments as needed. This structured process ensures that decisions are informed, ethical, and effective in protecting worker health. Question 4. Process analysis reveals that understanding the historical development of ergonomics is crucial for a certified ergonomics professional (CEP) to effectively apply current principles. Which of the following best represents a foundational influence on the early development of ergonomics, shaping its core focus on the human-system interaction? Option A. The emergence of virtual reality simulation for complex surgical training. Option B. The widespread adoption of early assembly line techniques and the subsequent scientific management principles aimed at optimizing worker efficiency. Option C. The development of advanced computational fluid dynamics for simulating airflow in industrial settings. Option D. The proliferation of social media platforms and their impact on user interface design. The correct answer is B. The widespread adoption of early assembly line techniques and the subsequent scientific management principles aimed at optimizing worker efficiency. Explanation. This scenario is professionally challenging because it requires an understanding of the foundational principles that shape the field of ergonomics, specifically within the context of its historical development. A certified ergonomics professional (CEP) must be able to articulate the evolution of ergonomic thought and practice, recognizing how early influences continue to inform current methodologies and regulatory frameworks. The challenge lies in distinguishing between genuine historical milestones and less impactful or tangential developments, ensuring that the professional's knowledge is grounded in the core evolution of the discipline. The correct approach involves identifying the seminal contributions and conceptual shifts that define the early stages of ergonomics. This includes recognizing the influence of scientific management, human factors engineering, and early industrial psychology on the development of systematic approaches to workplace design and human performance optimization. Regulatory and ethical justification stems from the CEP's responsibility to practice based on established knowledge and evidence. Understanding the historical trajectory provides the context for why current ergonomic principles and standards exist, ensuring that interventions are evidence-based and aligned with the discipline's core tenets. An incorrect approach would be to focus on isolated technological advancements without understanding the underlying ergonomic principles they were designed to address or were influenced by. This fails to grasp the conceptual evolution of ergonomics. Another incorrect approach is to conflate ergonomics with general occupational safety or industrial engineering without acknowledging its specific focus on the human-system interface and the scientific study of human capabilities and limitations. This dilutes the unique contribution of ergonomics. Finally, an approach that prioritizes anecdotal evidence or isolated case studies over the systematic development of principles and research would be professionally unsound, as it lacks the rigor and historical grounding expected of a CEP. Professionals should employ a decision-making framework that prioritizes understanding the lineage of ergonomic thought. This involves tracing the intellectual roots of the field, identifying key researchers and their contributions, and recognizing the paradigm shifts that occurred. When evaluating information or developing strategies, a CEP should ask, Does this align with the foundational principles and historical evolution of ergonomics, or is it a superficial application or a misinterpretation of its core development? This critical self-assessment ensures that practice is informed by a deep understanding of the discipline's past. Question 5. The monitoring system demonstrates that key ergonomic risk factors, such as force exertion and repetition, are within acceptable limits for a specific assembly line task. However, several experienced operators have consistently reported experiencing discomfort and fatigue during and after their shifts, attributing it to the task. Which of the following approaches best addresses this discrepancy to ensure effective ergonomics and risk management? Option A. Rely solely on the data from the monitoring system, concluding that the operator's reported discomfort is likely due to individual factors or a lack of acclimatization, and advise them to manage their fatigue through personal means. Option B. Initiate a series of ergonomic training sessions for the operators, focusing on proper body mechanics, and assume that improved technique will resolve the reported discomfort without further investigation into the task or monitoring data. Option C. Conduct a detailed task analysis involving direct observation of the operators performing the task. Conduct semi-structured interviews with the operators to understand the nature and context of their reported discomfort, and review the calibration and data collection methodology of the monitoring system to ensure its accuracy and relevance to the specific task. Option D. Immediately implement significant changes to the workstation layout and tool design across the entire assembly line, assuming the operator's feedback accurately reflects a widespread ergonomic issue that the monitoring system has failed to detect. The correct answer is C. Conduct a detailed task analysis involving direct observation of the operators performing the task. Conduct semi-structured interviews with the operators to understand the nature and context of their reported discomfort, and review the calibration and data collection methodology of the monitoring system to ensure its accuracy and relevance to the specific task. Explanation. Scenario analysis. This scenario presents a common challenge in ergonomics where objective data from a monitoring system conflicts with subjective employee feedback. The professional challenge lies in balancing these two sources of information to ensure effective risk management without alienating the workforce or overlooking critical hazards. A failure to appropriately address this discrepancy could lead to continued exposure to ergonomic risks, potential injuries, and a breakdown in trust between management and employees. Careful judgment is required to interpret the data, validate concerns, and implement appropriate interventions. Correct approach analysis. The correct approach involves a multifaceted strategy that acknowledges both the quantitative data and the qualitative employee feedback. It prioritizes a thorough investigation that includes direct observation of tasks, interviews with affected employees to understand the context of their feedback, and a review of the monitoring system's calibration and data collection methodology. This approach is justified by the principles of good ergonomic practice, which emphasize a holistic assessment of the work environment. Furthermore, it aligns with regulatory frameworks that mandate employers to identify and control workplace hazards, often requiring a combination of objective measurement and employee input to achieve this. Ethical considerations also dictate that employee concerns should be taken seriously and investigated thoroughly. Incorrect approach is analysis. An approach that solely relies on the monitoring system's data and dismisses employee concerns is professionally unacceptable. This fails to recognize that monitoring systems, while valuable, may not capture all aspects of a task's ergonomic risk or may have limitations in their scope. It also disregards the direct experience of the individuals performing the work, who are often the first to identify subtle or emerging issues. This approach risks violating regulatory requirements to proactively manage hazards and can lead to a perception of management indifference, eroding trust and potentially leading to underreporting of future issues. An approach that exclusively prioritizes employee feedback without considering the objective data is also professionally flawed. While employee input is crucial, it can sometimes be influenced by factors unrelated to objective ergonomic risk, such as personal preferences or temporary discomfort. Without validating these concerns with objective data and further investigation, resources might be misallocated, and interventions may not address the root cause of any actual ergonomic hazard. This can lead to inefficient use of resources and a failure to implement the most effective controls, potentially leaving genuine risks unaddressed. An approach that involves immediate, broad-stroke changes based solely on the discrepancy, without a systematic investigation, is also problematic. This can lead to unnecessary disruption, cost, and may not effectively target the actual ergonomic risks. It bypasses the critical step of understanding the underlying causes of the discrepancy between the monitoring data and employee feedback, which is essential for developing targeted and sustainable solutions. This reactive approach can be inefficient and may not comply with the systematic hazard identification and control processes often mandated by regulations. Professional reasoning. Professionals should adopt a systematic, evidence-based approach. When faced with conflicting data sources, the decision-making process should involve 1. Acknowledging and validating all data sources, both quantitative and qualitative. 2. Conducting a comprehensive investigation that bridges the gap between these sources, including direct observation, interviews, and a review of data collection methods. 3. Analyzing the findings to identify the root causes of any discrepancies and the actual ergonomic risks. 4. Developing and implementing targeted, evidence-based interventions. 5. Communicating findings and actions to affected employees to foster trust and collaboration. This iterative process ensures that risk management strategies are both scientifically sound and practically effective. Question 6. The efficiency study reveals that a manufacturing team is consistently falling short of its production targets, with supervisors attributing this to slow task completion. The team leader suggests that simply rearranging the workstations to be closer together will allow workers to reach materials more quickly, thereby increasing output. As a certified ergonomics professional, CEP, tasked with evaluating this situation, which of the following approaches best aligns with foundational ergonomic principles and regulatory expectations for ensuring a safe and healthy work environment? Option A. Focus on implementing a new, faster-paced work rotation schedule for the team, assuming that increased task variety will naturally lead to improved efficiency and reduced fatigue, without a detailed ergonomic analysis of the tasks themselves. Option B. Recommend the purchase of new, more advanced tools that are advertised to increase speed, without first evaluating whether the current tools are being used in an ergonomically sound manner, or if the tasks themselves pose significant physical risks. Option C. Implement the suggested workstation rearrangement immediately, as the team leader's proposal directly addresses the perceived need for faster material access and is a straightforward solution to boost efficiency. Option D. Conduct a comprehensive ergonomic risk assessment of the current workstations and tasks, including direct observation of work methods, worker feedback on physical discomfort, and analysis of biomechanical demands, to identify underlying ergonomic issues that may be contributing to perceived inefficiencies, and then propose targeted interventions based on this assessment. The correct answer is D. Conduct a comprehensive ergonomic risk assessment of the current workstations and tasks, including direct observation of work methods, worker feedback on physical discomfort, and analysis of biomechanical demands, to identify underlying ergonomic issues that may be contributing to perceived inefficiencies, and then propose targeted interventions based on this assessment. Explanation. This scenario presents a professional challenge because it requires balancing the immediate perceived need for increased productivity with the fundamental ethical and regulatory obligations of a certified ergonomics professional, CEP, to prioritize worker well-being and safety. The pressure to demonstrate tangible efficiency gains can create a conflict of interest, tempting a professional to overlook subtle but significant ergonomic risks. Careful judgment is required to ensure that any proposed solutions are evidence-based and do not inadvertently introduce new hazards or exacerbate existing ones, thereby violating professional standards and potentially regulatory requirements. The correct approach involves a comprehensive ergonomic assessment that goes beyond superficial efficiency metrics. This approach prioritizes identifying the root causes of any perceived inefficiencies, which may be linked to poor workstation design, inadequate task sequencing, or excessive physical demands. By conducting a thorough risk assessment, including direct observation, worker interviews, and potentially biomechanical analysis, the CEP can gather objective data to inform recommendations. This aligns with the core principles of ergonomics, which aim to optimize the interaction between humans and their work environment to improve well-being and system performance. Ethically and regulatorily, this is justified by the CEP's commitment to preventing work-related musculoskeletal disorders, WMSD, and ensuring compliance with relevant occupational safety and health regulations, which mandate a safe working environment. An incorrect approach that focuses solely on minor adjustments to workstation layout without addressing underlying biomechanical stressors would be professionally unacceptable. This fails to uphold the CEP's duty to conduct a thorough risk assessment and could lead to the perpetuation or even worsening of ergonomic hazards. Such an approach neglects the foundational principles of ergonomics, which emphasize understanding the interplay of physical, cognitive, and organizational factors. Ethically, this constitutes a failure to act in the best interest of the worker and could violate professional codes of conduct that require due diligence and evidence-based practice. Another incorrect approach that proposes increasing the pace of work without a corresponding ergonomic evaluation would be a significant ethical and regulatory failure. This directly contradicts the goal of ergonomics, which is to reduce physical demands and improve comfort, not to increase them under the guise of efficiency. Such an action could lead to an increase in WMSD, placing workers at risk and potentially violating occupational safety and health laws that require employers to provide a safe workplace. It demonstrates a disregard for the scientific principles of ergonomics and a prioritization of output over human health. A third incorrect approach that involves implementing a one-size-fits-all solution without considering individual worker variations or task-specific demands would also be professionally unsound. Ergonomics recognizes that individuals have different anthropometric characteristics and that tasks can vary in their physical requirements. Failing to account for this variability can lead to solutions that are ineffective for some workers or even create new ergonomic problems. This approach lacks the analytical rigor expected of a CEP and fails to meet the ethical obligation to provide tailored, effective solutions. The professional decision-making process for similar situations should involve a structured, systematic approach. First, clearly define the problem and the stated objectives, e.g., efficiency improvement. Second, gather comprehensive data through observation, interviews, and objective measurements, focusing on both performance metrics and ergonomic risk factors. Third, analyze the data to identify the root causes of any issues, distinguishing between perceived inefficiencies and actual ergonomic hazards. Fourth, develop evidence-based recommendations that address identified risks and align with ergonomic principles and regulatory requirements. Fifth, communicate findings and recommendations clearly to stakeholders, emphasizing the long-term benefits of ergonomic interventions for both worker well-being and sustainable productivity. Finally, monitor the effectiveness of implemented solutions and make adjustments as needed. Question 7. The performance metrics show a consistent output from the assembly line workers, yet multiple employees have reported experiencing new or worsening pain in their wrists, elbows, and shoulders over the past quarter. As a certified ergonomics professional, CEP, tasked with investigating these reports, which of the following approaches would be the most appropriate and professionally responsible course of action? Option A. Advise management that since performance metrics remain high, the reported discomfort is likely unrelated to the work tasks and may be due to individual lifestyle factors. Option B. Conduct a detailed job task analysis for each affected employee's role, observing their postures, movements, and force application, while simultaneously conducting individual interviews to understand the nature and location of their discomfort. Option C. Rely solely on the employee's self-reported pain levels and locations to recommend immediate changes to their workstations, without observing the tasks being performed. Option D. Implement a standardized ergonomic training program for all assembly line workers, focusing on general principles of posture and stretching, without further site-specific investigation. Correct answer is B. Conduct a detailed job task analysis for each affected employee's role, observing their postures, movements, and force application, while simultaneously conducting individual interviews to understand the nature and location of their discomfort. Explanation. Scenario analysis. This scenario presents a common challenge in ergonomics where objective performance data conflicts with subjective employee reports of discomfort. The challenge lies in accurately diagnosing the root cause of the reported musculoskeletal issues, which could stem from various factors including the workstation design, task demands, individual employee characteristics, or a combination thereof. A hasty or incomplete assessment risks misdiagnosis, leading to ineffective interventions, potential escalation of injuries, and erosion of trust between employees and the ergonomics professional. The Certified Ergonomics Professional (CEP) designation implies a commitment to rigorous, evidence-based assessment and adherence to established professional standards and relevant regulations. Correct approach analysis. The correct approach involves a comprehensive, multifaceted investigation that prioritizes direct observation and employee engagement. This aligns with the core principles of ergonomic assessment, which mandate a thorough understanding of the work environment and the human factors involved. Specifically, it requires a detailed job task analysis to understand the physical demands placed on the musculoskeletal system, bones, muscles, joints, ligaments, tendons, during the performance of the task. This includes observing posture, force application, repetition, and duration of exposure. Simultaneously, conducting direct interviews with the affected employees is crucial to gather subjective data on pain location, intensity, and triggers, which can corroborate or contextualize objective findings. This integrated approach ensures that interventions are targeted and effective, addressing the actual biomechanical stressors contributing to musculoskeletal discomfort. While specific U.S. regulations for ergonomics are not universally mandated across all industries, the General Duty Clause of the Occupational Safety and Health Act, OSH Act, requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. Ergonomic principles and best practices, as espoused by professional bodies like the Board of Certification for Professional Ergonomists, BCPE, for CEPs, guide the implementation of such hazard mitigation. Incorrect approaches analysis. Relying solely on the performance metrics to dismiss employee complaints is a significant ethical and professional failure. Performance metrics, while useful indicators of productivity, do not directly measure biomechanical load or the physiological response of the musculoskeletal system. This approach ignores the subjective experience of the employee, which is a critical component of identifying ergonomic risk factors. It also fails to comply with the spirit of the OSH Act's General Duty Clause by not proactively investigating potential hazards. Implementing a generic, one-size-fits-all ergonomic solution without a specific assessment of the tasks and employee complaints is also professionally unsound. This approach assumes a universal cause for discomfort, which is rarely the case in complex work environments. It risks being ineffective, wasting resources, and failing to address the specific biomechanical stressors contributing to the employee's musculoskeletal issues. This demonstrates a lack of due diligence and a failure to apply specialized ergonomic knowledge. Focusing exclusively on employee self-reporting without objective observation or task analysis is also insufficient. While employee feedback is vital, it needs to be validated and contextualized by an objective assessment of the work environment and task demands. Without this, it is difficult to pinpoint the exact ergonomic stressors and design appropriate interventions. This approach may lead to misinterpretations of the problem and the implementation of interventions that do not address the root cause. Professional reasoning. When faced with conflicting data, a certified ergonomics professional must employ a systematic, evidence-based approach. This involves 1. Acknowledging and validating all data sources, both objective performance metrics and subjective employee reports. 2. Prioritizing direct observation and detailed job task analysis to understand the biomechanical demands of the work. 3. Engaging in thorough interviews with affected employees to gather qualitative data on their experiences. 4. Synthesizing all gathered information to identify potential ergonomic risk factors affecting the musculoskeletal system. 5. Developing and recommending targeted, evidence-based interventions based on the comprehensive assessment. 6. Documenting the entire process, findings, and recommendations for accountability and future reference. Question 8. Strategic planning requires a thorough understanding of how new technologies integrate with existing human capabilities and organizational processes. A company is considering implementing a sophisticated new automated data entry system. While the system promises increased speed and accuracy in data processing, initial observations suggest that the user interface is complex, requires a high degree of fine motor control, and lacks clear error feedback mechanisms. The project manager is eager to deploy the system quickly to realize its perceived benefits. Which of the following approaches best aligns with the principles of human factors and systems thinking for the successful integration of this new technology? Option A. Focus solely on the technical specifications and performance metrics of the automated system, as these are the primary drivers of efficiency. Option B. Rely on the IT department's assessment of the system's technical feasibility and the opinions of a few experienced users to guide the implementation. Option C. Conduct a comprehensive human factors analysis to evaluate the system's usability, cognitive load, and potential for error, and develop a phased implementation plan that includes user training, pilot testing, and feedback mechanisms. Option D. Prioritize rapid deployment of the system to meet the project manager's deadline, assuming that users will adapt over time with minimal additional support. The correct answer is C. Conduct a comprehensive human factors analysis to evaluate the system's usability, cognitive load, and potential for error, and develop a phased implementation plan that includes user training, pilot testing, and feedback mechanisms. Explanation. This scenario presents a common challenge in ergonomics where a new technology is introduced without adequate consideration of the human element, potentially leading to user errors, reduced efficiency, and safety risks. The professional challenge lies in balancing the perceived benefits of the new system with the actual capabilities and limitations of the human operators. A CEP must apply human factors principles in systems thinking to ensure the technology is integrated effectively and safely, rather than simply being adopted. This requires a proactive, holistic approach that considers the entire system, including people, tools, tasks, and the environment. The correct approach involves a comprehensive human factors analysis and integration plan. This entails systematically evaluating the new technology's impact on user performance, cognitive load, physical demands, and potential for error. It requires engaging end users in the design and implementation process, conducting usability testing, and developing appropriate training and support mechanisms. This aligns with the ethical obligation of a CEP to prioritize human well-being and safety, and the regulatory expectation to implement systems that are effective and minimize risk. By focusing on the human-system interface, this approach ensures that the technology serves its intended purpose without compromising the health, safety, or productivity of the workforce. An incorrect approach that focuses solely on the technical specifications of the new system, without considering the human operators, fails to acknowledge the fundamental principles of human factors. This overlooks the potential for mismatch between the system's design and human capabilities, leading to increased error rates, user frustration, and potential injury. Ethically, this is a failure to uphold the duty of care to the workforce. Another incorrect approach that prioritizes rapid implementation to meet a deadline, at the expense of thorough human factors evaluation and user training, is also professionally unacceptable. This demonstrates a disregard for potential negative consequences and prioritizes expediency over safety and effectiveness. Regulatory frameworks often mandate risk assessments and adequate training for new technologies, which this approach would bypass. A third incorrect approach that relies on anecdotal evidence or the opinions of a few individuals without systematic data collection or analysis is insufficient. Human factors and systems thinking require objective data and rigorous evaluation to identify potential issues and develop evidence-based solutions. Relying on assumptions or limited feedback can lead to overlooking critical design flaws or user challenges. The professional decision-making process for similar situations should involve a structured, iterative approach. First, clearly define the problem and the scope of the intervention. Second, gather comprehensive data through observation, interviews, and task analysis, focusing on the human-system interaction. Third, apply established human factors principles and systems thinking methodologies to identify potential risks and opportunities for improvement. Fourth, develop and test potential solutions, involving end users throughout the process. Finally, implement the chosen solution with appropriate training and ongoing monitoring to ensure its effectiveness and safety. Question 9. What factors determine the most appropriate ergonomic intervention for a manufacturing associate experiencing lower extremity discomfort during prolonged standing and repetitive squatting motions, considering U.S. regulatory requirements for workplace safety? Option A. The employer's budget for ergonomic improvements and the perceived impact of the associate's discomfort on overall production output. Option B. The associate's personal footwear choices and their general fitness level, irrespective of specific task demands. Option C. The availability of pre-designed ergonomic equipment that has been shown to reduce general lower extremity strain in similar industries. Option D. The associate's subjective report of pain intensity and location, combined with objective biomechanical measurements of hip, knee, and ankle joint angles and forces during task performance, and an analysis of the task's cycle time and frequency. Correct answer is D. The associate's subjective report of pain intensity and location, combined with objective biomechanical measurements of hip, knee, and ankle joint angles and forces during task performance, and an analysis of the task's cycle time and frequency. Explanation. This scenario presents a professional challenge for a certified ergonomics professional CEP, tasked with evaluating a worker's lower extremity biomechanics in a manufacturing setting. The challenge lies in balancing the need for objective biomechanical assessment with the subjective experience of the worker and the practical constraints of the workplace, all while adhering to the specific regulatory framework governing ergonomics in the United States, as implied by the CEP certification. The CEP must ensure their recommendations are not only scientifically sound, but also legally defensible and ethically responsible, considering potential impacts on worker health, productivity, and employer liability. The correct approach involves a comprehensive assessment that integrates direct observation of the worker performing tasks, measurement of relevant biomechanical parameters, e.g., joint angles, forces, postures, and a thorough understanding of the worker's reported symptoms and medical history. This approach aligns with the principles of good ergonomic practice and the General Duty Clause of the Occupational Safety and Health Act, OSH Act, in the U.S., which requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. Specific OSHA standards, such as those related to manual handling or specific industry guidelines, may also be relevant. Ethical considerations, including worker confidentiality and informed consent, are paramount. An incorrect approach would be to solely rely on the worker's subjective report of pain, without objective biomechanical data. This fails to provide a complete picture and could lead to misdiagnosis or ineffective interventions. Ethically, it might be seen as not fully investigating the root cause of the issue. Another incorrect approach would be to focus exclusively on biomechanical measurements without considering the worker's reported symptoms or the context of their work tasks. This could lead to recommendations that are technically accurate but practically unworkable, or that fail to address the worker's actual discomfort. This neglects the human element crucial to effective ergonomics. A third incorrect approach would be to implement generic, one-size-fits-all solutions without a specific assessment of the individual worker and their tasks. This is unlikely to be effective and could be considered a failure to meet the employer's obligation to address specific workplace hazards. The professional decision-making process should involve a systematic approach. First, understanding the worker's reported symptoms and medical history. Second, observing the worker performing their tasks to identify specific postures, movements, and forces that may be contributing to the symptoms. Third, collecting objective biomechanical data to quantify the risk factors. Fourth, analyzing this data in conjunction with the observed tasks and reported symptoms. And finally, developing and recommending evidence-based, task-specific interventions that are practical and address the identified risks, all within the framework of U.S. occupational safety and health regulations. Question 10. Examination of the data shows a manufacturing client has expressed significant concern about the cost of implementing recommended ergonomic improvements identified in a recent assessment. They are requesting a proposal that minimizes upfront investment, even if it means delaying some of the more comprehensive solutions. As a certified ergonomics professional, CEP, what is the most appropriate approach to address this situation while adhering to regulatory frameworks and professional ethics? Option A. Present a proposal that focuses exclusively on the least expensive solutions, even if they do not fully address the identified ergonomic hazards, to satisfy the client's immediate budget concerns. Option B. Omit any discussion of potential legal liabilities or regulatory requirements in the proposal to avoid alarming the client and focus solely on the ergonomic benefits of the proposed solutions. Option C. Advise the client that all recommended ergonomic improvements must be implemented immediately to avoid legal repercussions, regardless of their budget constraints. Option D. Develop a phased implementation plan that prioritizes immediate, cost-effective interventions to mitigate the most critical risks, clearly outlining the long-term benefits and legal advantages of subsequent phases, and providing evidence of potential cost savings from injury reduction. The correct answer is D. Develop a phased implementation plan that prioritizes immediate, cost-effective interventions to mitigate the most critical risks, clearly outlining the long-term benefits and legal advantages of subsequent phases, and providing evidence of potential cost savings from injury reduction. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the immediate financial pressures of a client with the long-term legal and ethical obligations related to workplace safety and ergonomics. The client's desire to avoid costly retrofits presents a direct conflict with the ergonomist's duty to recommend necessary interventions to prevent injuries, which are often mandated or strongly implied by regulatory frameworks. The ergonomist must navigate this conflict by providing evidence-based recommendations and clearly articulating the legal ramifications of inaction without alienating the client. Correct approach analysis. The correct approach involves a thorough ergonomic assessment, identification of specific hazards, and the development of a prioritized list of recommendations, including cost-effective interim solutions alongside long-term improvements. This approach is correct because it directly addresses the client's concerns about cost while fulfilling the ergonomist's professional responsibility to advocate for worker safety. It aligns with the principles of due diligence expected under regulatory frameworks such as the Occupational Safety and Health Act, OSH Act, in the U.S., which requires employers to provide a workplace free from recognized hazards. By presenting a phased approach and demonstrating how even interim measures can mitigate risk, the ergonomist empowers the client to make informed decisions that comply with legal obligations and protect employees. This also reflects the ethical guidelines of professional ergonomics organizations, which emphasize the importance of evidence-based practice and client education. Incorrect approach is analysis. An approach that focuses solely on the client's immediate budget constraints without adequately addressing the identified ergonomic risks is incorrect. This failure to prioritize worker safety and legal compliance could expose the client to significant liability under the OSH Act, including citations, fines, and potential lawsuits if injuries occur. It also violates the professional's ethical duty to advocate for safe working conditions. An approach that presents a comprehensive, high-cost solution without offering any phased or interim options is also problematic. While it addresses the ergonomic issues, it may be perceived as unrealistic by the client, leading to the rejection of all recommendations and potentially no action being taken. This can indirectly lead to non-compliance and increased risk. An approach that avoids mentioning any legal implications or potential liabilities to the client, even when significant ergonomic risks are identified, is professionally negligent. This omission prevents the client from fully understanding the consequences of inaction and fails to uphold the ergonomist's responsibility to inform stakeholders about relevant legal obligations. Professional reasoning. Professionals should adopt a systematic approach that begins with a comprehensive risk assessment. This assessment should be followed by the development of a clear, prioritized list of recommendations, categorized by urgency and potential impact. Crucially, these recommendations should be presented with an understanding of the client's operational and financial context, offering a range of solutions from immediate, low-cost interventions to longer-term, more significant improvements. The professional must then clearly communicate the rationale behind each recommendation, including the potential health benefits for workers and the legal and financial implications of both implementing and neglecting these recommendations, referencing relevant regulatory standards where applicable. This transparent and collaborative approach fosters trust and facilitates informed decision-making that prioritizes both worker well-being and organizational compliance. Question 11. When evaluating the implementation of new automated equipment designed to reduce manual lifting in a warehouse environment, what is the most appropriate ergonomic approach to ensure worker well-being and compliance with U.S. occupational safety regulations, considering the potential shift in physical demands from gross motor skills to more fine motor skills and sustained postures? Option A. Conduct a comprehensive physiological assessment of workers performing tasks with the new equipment, focusing on the interplay of aerobic and anaerobic energy expenditure during both routine operations and potential non-routine tasks, and use this data to inform work rest schedules and task rotation. Option B. Rely solely on worker feedback regarding comfort levels and perceived exertion after the equipment has been in use for a month to identify any necessary adjustments. Option C. Implement standard ergonomic guidelines for seated or standing work without specific analysis of the new equipment's impact on sustained postures or fine motor skill demands. Option D. Prioritize the speed and efficiency of the new automated equipment, assuming that any reduction in manual lifting inherently eliminates significant ergonomic risks. The correct answer is A. Conduct a comprehensive physiological assessment of workers performing tasks with the new equipment, focusing on the interplay of aerobic and anaerobic energy expenditure during both routine operations and potential non-routine tasks, and use this data to inform work rest schedules and task rotation. Explanation. This scenario presents a professional challenge because it requires an ergonomist to balance the immediate need for productivity with the long-term health and safety of workers, particularly when dealing with tasks that demand significant physical exertion. The core of the challenge lies in accurately assessing the physiological demands of a job and translating that into actionable ergonomic interventions that do not compromise operational efficiency or worker well-being. The Certified Ergonomics Professional (CEP) designation implies a commitment to upholding established ergonomic principles and adhering to relevant regulatory frameworks, which in the U.S. context primarily involves OSHA standards and best practices. The correct approach involves a comprehensive assessment that considers both aerobic and anaerobic energy metabolism to understand the full physiological load on workers. This means recognizing that prolonged, moderate-intensity tasks primarily rely on aerobic pathways, while short bursts of high-intensity effort engage anaerobic pathways. An ergonomist must identify tasks that push workers towards their physiological limits, leading to fatigue, increased risk of musculoskeletal disorders, MSD, and potential for errors. By implementing interventions that manage these demands, such as optimizing work rest cycles, improving tool design to reduce force requirements, or resequencing tasks to distribute physical load, the ergonomist can mitigate risks. This aligns with OSHA General Duty Clause, which requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. Furthermore, it adheres to the ethical imperative of protecting worker health and safety, a cornerstone of professional ergonomics practice. An incorrect approach would be to solely focus on perceived worker complaints without a systematic physiological assessment. While worker feedback is valuable, it may not always pinpoint the root cause of fatigue or injury, which could be related to the interplay of aerobic and anaerobic demands. Relying solely on this could lead to superficial solutions that don't address the underlying physiological stress. Another incorrect approach is to prioritize production targets above all else, assuming that workers can simply push through demanding tasks. This disregards the physiological limits of the human body and directly contravenes the principles of risk management and worker protection mandated by OSHA and professional ethical codes. Such an approach increases the likelihood of MSDs, leading to increased workers' compensation claims, lost productivity due to injuries, and potential regulatory citations. A third incorrect approach is to implement generic ergonomic solutions without a task-specific analysis of energy metabolism. This can be inefficient and ineffective, as it fails to address the unique physiological demands of different job roles and tasks. The professional reasoning process for such situations should involve a systematic, data-driven approach. First, conduct a thorough job analysis, observing tasks and identifying potential ergonomic risk factors. Second, gather objective data, which may include biomechanical measurements, but also, crucially, an understanding of the physiological demands, including the contribution of aerobic and anaerobic pathways to overall energy expenditure. Third, consult with workers to understand their experiences and perceptions. Fourth, use this comprehensive information to identify high-risk tasks and develop targeted interventions. Finally, implement, monitor, and evaluate the effectiveness of these interventions, making adjustments as needed to ensure both worker safety and operational effectiveness. This iterative process ensures that interventions are evidence-based and aligned with regulatory requirements and ethical obligations. Question 12. Compliance review shows that a warehouse operator frequently lifts boxes with a center of gravity that shifts significantly during the lift, and the base of support is sometimes compromised due to aisle congestion. The operator states they have always done it this way, and have never dropped a box or injured themselves. The supervisor is concerned about potential future incidents, but is hesitant to implement changes that might slow down operations. As a certified ergonomics professional, what is the most appropriate course of action? Option A. Conduct a detailed biomechanical analysis of the lifting task, specifically evaluating the dynamic center of gravity relative to the base of support under various conditions, and present findings with recommendations for improved lifting techniques or environmental adjustments to mitigate instability risks. Option B. Immediately mandate a new, more complex lifting device without further analysis, assuming it will resolve the stability issue. Option C. Suggest the operator simply be more careful during the lifts, as their personal technique is the primary factor. Option D. Advise the supervisor that since no incidents have occurred, no action is necessary and the operator's experience should be trusted. The correct answer is A. Conduct a detailed biomechanical analysis of the lifting task, specifically evaluating the dynamic center of gravity relative to the base of support under various conditions, and present findings with recommendations for improved lifting techniques or environmental adjustments to mitigate instability risks. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for operational efficiency with the long-term responsibility of ensuring worker safety, specifically concerning the principles of center of gravity and stability. The challenge lies in interpreting and applying ergonomic principles in a context where a perceived minor deviation from ideal practice could have significant consequences. Careful judgment is required to assess the actual risk versus the perceived risk, and to communicate these findings effectively to stakeholders who may prioritize productivity. The correct approach involves a thorough, data-driven assessment of the load center of gravity relative to the base of support during the proposed lifting operation. This assessment should consider the dynamic nature of the lift and potential environmental factors. The professional must then use this data to determine if the current method, or a proposed modification, maintains an acceptable margin of stability, preventing uncontrolled movement or tipping. This aligns with the ethical obligation of a certified ergonomics professional to prioritize the health and safety of individuals by applying scientific principles to reduce risk. Specifically, it adheres to the fundamental ergonomic principle that understanding and controlling the center of gravity is crucial for preventing musculoskeletal injuries and accidents related to instability. An incorrect approach would be to dismiss the concern based on the operator's perceived experience or the perceived infrequency of the issue. This fails to acknowledge the inherent variability in human performance and the potential for unforeseen circumstances. Ethically, it neglects the duty of care to all workers, not just those who may be currently unaffected. Relying solely on anecdotal evidence or the absence of past incidents is a failure to proactively identify and mitigate risks, which is a core tenet of professional ergonomics practice. Another incorrect approach would be to implement a drastic, unverified solution without proper assessment. This could introduce new risks or be unnecessarily disruptive, failing to demonstrate a reasoned, evidence-based approach to problem solving, and potentially violating the principle of acting in the best interest of both the worker and the organization. Professionals should approach such situations by first gathering all relevant information, including task analysis, environmental conditions, and equipment specifications. They should then apply established ergonomic principles and methodologies to assess the risk. Communication of findings should be clear, objective, and supported by evidence. When recommending changes, the rationale should be explained, focusing on the reduction of risk and the scientific basis for the recommendation. If faced with resistance, the professional should be prepared to explain the potential consequences of inaction and to explore alternative solutions collaboratively, always prioritizing safety. Question 13. Market research demonstrates that a new automated system could significantly increase production output by reducing manual material handling and streamlining assembly line movements. As a certified ergonomics professional, CEP, what is the most critical consideration when evaluating the implementation of this new system to ensure compliance with U.S. regulatory frameworks and ethical practice regarding the skeletal system? Option A. Implementing the new system immediately to capitalize on the market opportunity, with a plan to address any ergonomic issues that may arise post-implementation. Option B. Focusing on the cost-effectiveness of the automation, ensuring that the investment yields a significant return on investment within the first year of operation. Option C. Conducting a comprehensive ergonomic assessment to evaluate the biomechanical demands of the new system on the skeletal system, including postures, forces, and repetitions, and identifying potential risks for musculoskeletal disorders. Option D. Prioritizing the reduction of cycle times and material handling distances to maximize the efficiency gains promised by the automated system. The correct answer is C. Conducting a comprehensive ergonomic assessment to evaluate the biomechanical demands of the new system on the skeletal system, including postures, forces, and repetitions, and identifying potential risks for musculoskeletal disorders. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a certified ergonomics professional, CEP, to balance the immediate need for process optimization with the fundamental responsibility of ensuring worker safety and health, specifically concerning the skeletal system. Misinterpreting or neglecting the structural and functional limitations of the human skeletal system can lead to the implementation of processes that, while potentially efficient in the short term, pose significant long-term risks of musculoskeletal disorders. MSD. The CEP must exercise careful judgment to avoid prioritizing productivity over the well-being of individuals, adhering strictly to the ethical and regulatory standards governing their practice. Correct approach analysis. The correct approach involves conducting a thorough ergonomic assessment that explicitly considers the biomechanical demands placed on the skeletal system during the proposed process changes. This includes evaluating postures, forces, repetitions, and durations of tasks to identify potential stressors that could compromise skeletal integrity or function. The justification for this approach lies in the core principles of ergonomics and the ethical obligations of a CEP, which are underpinned by regulatory frameworks like the Occupational Safety and Health Act (OSHA). In the U.S., OSHA General Duty Clause requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. MSD, stemming from skeletal system compromise, falls squarely within this definition. A CEP's role is to proactively identify and mitigate these hazards, ensuring that process optimization does not inadvertently create or exacerbate risks to the skeletal system. This aligns with the professional standard of care, which mandates a holistic approach that integrates efficiency with human factors. Incorrect approach is analysis. Implementing process changes solely based on observed efficiency gains, without a detailed ergonomic evaluation of skeletal system impact, is professionally unacceptable. This approach fails to meet the regulatory requirement of hazard identification and mitigation. It prioritizes output over worker well-being, potentially leading to an increase in MSDs, which are a direct consequence of overloading or improperly stressing the skeletal system. This violates the ethical duty of a CEP to protect worker health. Adopting process changes that introduce new, repetitive, or forceful movements without assessing their cumulative effect on joints, bones, and connective tissues is also professionally unsound. The skeletal system is designed for specific ranges of motion and load-bearing capacities. Exceeding these without proper controls or modifications can lead to microtrauma and long-term damage. This approach neglects the functional limitations of the skeletal system and disregards the potential for chronic injury, a clear ethical and regulatory failure. Focusing optimization efforts exclusively on reducing cycle times or material handling distances, while ignoring the postures and physical exertions required to achieve these reductions, is another flawed strategy. For instance, a shorter material path might necessitate awkward reaching or bending, placing undue stress on the spine and limbs. This demonstrates a superficial understanding of process optimization, failing to integrate the human element and the biomechanical realities of the skeletal system, thereby creating a hazardous work environment. Professional reasoning. Professionals should employ a systematic risk assessment framework. This involves identifying potential hazards, e.g., awkward postures, excessive force, analyzing the risk associated with these hazards, considering frequency, duration, and magnitude, and implementing control measures to eliminate or reduce the risk. When considering process optimization, the CEP must integrate this risk assessment into the design and implementation phases, ensuring that any proposed changes are evaluated for their impact on the skeletal system structure and function. This proactive, human-centered approach, grounded in regulatory compliance and ethical responsibility, is paramount. Question 14. Regulatory review indicates that a manufacturing facility is experiencing increased reports of worker discomfort and reduced output during prolonged assembly line tasks. An ergonomics professional is tasked with assessing the situation, focusing on the muscular system's response to these tasks, which approach best aligns with the Certified Ergonomics Professional CEP examination's regulatory framework and ethical guidelines for addressing potential muscle fatigue and its impact on worker health and productivity. Option A. Rely primarily on worker self-reports of tiredness and discomfort to determine the extent of fatigue, and suggest general stretching exercises for all employees during breaks. Option B. Focus on improving workstation lighting and general environmental comfort, assuming that any reported muscle fatigue is a secondary symptom unrelated to the specific biomechanical demands of the assembly tasks. Option C. Conduct a detailed analysis of the specific muscle groups engaged, the types of muscle contractions, isometric, concentric, eccentric, involved in the assembly tasks, and the duration and frequency of these contractions to identify physiological stressors contributing to fatigue, then recommend task modifications and rest breaks tailored to these findings. Option D. Implement immediate productivity targets to overcome the perceived slowdown, deferring any ergonomic assessments until after the current production cycle is completed. The correct answer is C. Conduct a detailed analysis of the specific muscle groups engaged, the types of muscle contraction, isometric, concentric, eccentric, involved in the assembly tasks, and the duration and frequency of these contractions to identify physiological stressors contributing to fatigue, then recommend task modifications and rest breaks tailored to these findings. Explanation. This scenario is professionally challenging because it requires an ergonomics professional to balance the immediate need for productivity with the long-term health and safety of workers, all while adhering to specific regulatory requirements. The core of the challenge lies in interpreting and applying the nuances of muscle physiology in the context of workplace tasks, and ensuring that interventions are not only effective, but also compliant with the relevant standards. Careful judgment is required to avoid oversimplification of complex biological processes and to ensure that recommendations are evidence-based and legally sound. The correct approach involves a thorough understanding of muscle fatigue mechanisms, including the distinction between localized and generalized fatigue, and how different types of muscle contractions, isometric, concentric, eccentric, contribute to these states. This understanding must then be directly linked to the specific tasks being performed and the potential for cumulative trauma disorders. The regulatory justification for this approach stems from the overarching duty of care mandated by occupational health and safety regulations, which require employers to identify and mitigate workplace hazards, including those that can lead to musculoskeletal injuries. Specifically, regulations often mandate risk assessments that consider the physiological demands placed on workers, and a deep understanding of muscle physiology is fundamental to conducting such assessments accurately. Ethical considerations also demand that professionals prioritize worker well-being over short-term production gains when there is a risk of harm. An incorrect approach that focuses solely on the subjective reporting of fatigue without objective assessment fails to meet regulatory requirements for hazard identification and control. Regulations typically require more than just employee complaints. They necessitate a systematic evaluation of the work environment and tasks. This approach is ethically deficient, as it risks overlooking underlying physiological stressors that may not be immediately apparent to the worker, but can lead to chronic injury. Another incorrect approach that prioritizes immediate task completion over any intervention, even when signs of fatigue are present, directly contravenes the principles of proactive risk management embedded in occupational health and safety legislation. This approach is a clear ethical failure, demonstrating a disregard for worker safety and potentially leading to significant health consequences and legal liabilities for the employer. It also ignores the long-term productivity losses associated with musculoskeletal injuries. A third incorrect approach that applies generic fatigue management strategies without considering the specific types of muscle contractions involved in the tasks is also problematic. Different contraction types place different stresses on muscle fibers and lead to fatigue through distinct mechanisms. A failure to differentiate can result in ineffective interventions that do not adequately address the root cause of fatigue and the associated risk of injury, thereby failing to meet the standard of care expected under regulatory frameworks. The professional decision-making process for similar situations should involve a systematic risk assessment framework. This begins with identifying tasks and the specific muscle groups and contraction types involved. Next, assess the duration, frequency, and intensity of these contractions. Correlate this objective assessment with subjective reports of fatigue and any observed signs of physical distress. Based on this comprehensive understanding, evaluate the potential for muscle fatigue and subsequent injury against established ergonomic principles and regulatory guidelines. Finally, develop and implement targeted interventions that address the identified physiological stressors and are compliant with all applicable laws and ethical standards, with a plan for ongoing monitoring and evaluation. Question 15. Strategic planning requires a certified ergonomics professional, CEP, to address an employee's reported discomfort in their workstation. The employee states they are experiencing pain and believes their current setup is the cause. What is the most appropriate initial approach for the CEP to take to ensure compliance with occupational health and safety principles and ethical practice? Option A. Inform the employee that ergonomic issues are primarily the individual's responsibility to manage, and that the organization cannot provide specific workstation interventions without a formal medical diagnosis. Option B. Immediately recommend and implement significant workstation modifications based on the employee's description of pain, assuming their assessment of the cause is accurate. Option C. Conduct a comprehensive workstation risk assessment, including observation, employee interview, and evaluation of the workstation's physical characteristics and task demands, to identify specific ergonomic hazards and recommend evidence-based control measures. Option D. Advise the employee to adjust their posture and take more frequent breaks, deferring any formal evaluation or intervention until the discomfort escalates significantly. The correct answer is C. Conduct a comprehensive workstation risk assessment, including observation, employee interview, and evaluation of the workstation's physical characteristics and task demands, to identify specific ergonomic hazards and recommend evidence-based control measures. Explanation. This scenario is professionally challenging because it requires an ergonomist to balance the immediate needs of an employee with the broader organizational responsibilities of ensuring a safe and productive work environment, all while adhering to specific regulatory frameworks. The core of the challenge lies in accurately assessing risk and implementing appropriate modifications without overstepping professional boundaries or neglecting established guidelines. The correct approach involves a systematic and evidence-based risk assessment process, directly aligned with the principles of occupational health and safety legislation. This approach prioritizes identifying hazards, evaluating the severity and likelihood of harm, and then recommending proportionate control measures. For the Certified Ergonomics Professional (CEP) exam, this would typically align with frameworks such as OSHA General Duty Clause in the U.S., which mandates employers provide a workplace free from recognized hazards likely to cause death or serious physical harm, and the principles outlined in relevant ANSI/HFES standards for ergonomic design and evaluation. The ethical imperative is to protect the worker's health while ensuring the employer's compliance and the sustainability of the workplace. An incorrect approach that focuses solely on the employee's subjective complaint without a formal evaluation fails to establish a clear link between the complaint and a workplace hazard, potentially leading to unnecessary or ineffective interventions. This neglects the employer's responsibility to conduct due diligence in hazard identification and control, which is a cornerstone of regulatory compliance. Another incorrect approach that involves implementing significant, costly modifications based on anecdotal evidence or a single observation, without a comprehensive risk assessment, can lead to inefficient resource allocation and may not address the root cause of the issue. This deviates from the principle of evidence-based practice and can be seen as unprofessional and potentially non-compliant with guidelines that emphasize cost-effectiveness and proportionality in risk management. A third incorrect approach that involves deferring all responsibility to the employee to manage their own discomfort without providing any ergonomic support or evaluation overlooks the employer's duty of care and the ergonomist's professional obligation to facilitate a safe working environment. This abdication of responsibility is ethically unsound and likely violates regulatory requirements for hazard mitigation. Professionals should employ a decision-making process that begins with understanding the scope of the request and the applicable regulatory framework. This involves gathering information through observation, employee interviews, and potentially objective measurements. The next step is to conduct a thorough risk assessment, documenting all findings and potential hazards. Based on this assessment, recommendations for modifications should be developed, prioritizing controls that are effective, feasible, and compliant with relevant standards and regulations. Communication with both the employee and management is crucial throughout this process to ensure understanding and buy-in for implemented solutions. Question 16. Cost-benefit analysis shows that implementing a comprehensive ergonomic program to reduce cardiovascular response to work will have a higher initial investment than a minimal intervention. However, the long-term benefits in terms of reduced health risks and potential productivity gains are significant. Given the regulatory framework of the United States, which approach should a certified ergonomics professional, CEP, recommend to management? Option A. Advise management to wait for definitive medical diagnosis of cardiovascular disease directly linked to specific job tasks before considering any interventions. Option B. Suggest relying solely on employee self-reported fatigue levels to guide intervention decisions, without objective physiological assessment or task analysis. Option C. Recommend the lowest upfront cost intervention, even if its effectiveness in reducing cardiovascular strain is questionable, to minimize immediate financial outlay. Option D. Recommend the comprehensive ergonomic program that directly addresses identified cardiovascular stressors, supported by evidence of effectiveness in reducing physiological strain. The correct answer is D. Recommend the comprehensive ergonomic program that directly addresses identified cardiovascular stressors, supported by evidence of effectiveness in reducing physiological strain. Explanation. Scenario analysis. This scenario is professionally challenging because it requires balancing the immediate financial implications of implementing ergonomic interventions with the long-term health and safety of employees, specifically concerning cardiovascular strain. The certified ergonomics professional CEP must navigate potential resistance from management focused on cost, while upholding their ethical and regulatory obligations to prevent occupational illness and injury. The CEP's judgment is critical in identifying the most effective and justifiable interventions. Correct approach analysis. The correct approach involves prioritizing interventions that directly address the identified cardiovascular stressors, supported by evidence of their effectiveness in reducing physiological strain. This aligns with the core principles of ergonomics, which aim to optimize human well-being and performance by designing systems and tasks that fit the worker. Specifically, in the U.S. context, this approach is grounded in the Occupational Safety and Health Act, OSH Act, which mandates employers provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. While the OSH Act doesn't explicitly detail cardiovascular response metrics, the General Duty Clause empowers OSHA to cite employers for hazards that lead to such harm, including those stemming from excessive physical exertion. Furthermore, professional ethical codes for ergonomists emphasize a commitment to worker health and safety above all else, necessitating proactive measures to mitigate risks like cardiovascular strain. Incorrect approaches analysis. An approach that solely focuses on the lowest upfront cost without considering the efficacy of the intervention in reducing cardiovascular strain is ethically and regulatorily flawed. This prioritizes short-term financial gain over worker well-being, potentially violating the employer's general duty to provide a safe workplace. Such an approach ignores the potential for long-term costs associated with cardiovascular disease, such as increased healthcare expenses, absenteeism, and workers' compensation claims, which can far outweigh initial intervention costs. An approach that delays implementation of any intervention until definitive medical diagnoses of cardiovascular disease are linked to specific job tasks is also problematic. This reactive stance is contrary to the proactive nature of occupational health and safety. Ergonomics aims to prevent illness and injury, not merely to respond after they have occurred. Waiting for diagnosis means employees have already been exposed to hazardous conditions, potentially leading to irreversible health consequences and violating the spirit, if not the letter, of occupational safety regulations. An approach that relies solely on employee self-reporting of fatigue without objective physiological assessment or task analysis to identify cardiovascular stressors is insufficient. While employee feedback is valuable, it may not always accurately reflect the underlying physiological demands or identify the root causes of cardiovascular strain. A comprehensive ergonomic assessment requires objective data to inform effective interventions and ensure compliance with safety standards. Professional reasoning. Professionals should employ a decision-making framework that integrates risk assessment, evidence-based practice, and regulatory compliance. This involves 1. Identifying and quantifying the specific physical demands of the work that contribute to cardiovascular strain, e.g., lifting, prolonged static postures, repetitive motions. 2. Reviewing scientific literature and industry best practices for interventions proven to mitigate these specific stressors. 3. Conducting a thorough cost-benefit analysis that includes not only upfront costs, but also potential long-term savings from reduced injuries, improved productivity, and lower healthcare expenditures. 4. Consulting relevant regulatory standards, e.g., OSHA guidelines, NIOSH recommendations, to ensure proposed solutions meet legal requirements. 5. Prioritizing interventions that offer the greatest reduction in cardiovascular risk while being feasible to implement. Question 17. The risk matrix shows a moderate risk score for tasks involving repetitive motions with awkward postures, a low risk score for tasks with high physical exertion but good posture, and a moderate risk score for tasks with prolonged static postures but minimal exertion. Considering the Certified Ergonomics Professional (CEP) exams focus on U.S. regulatory frameworks, which approach best aligns with the overarching goals of ergonomics. Option A. Prioritize interventions for the tasks with high physical exertion, as this poses the greatest immediate physical demand on workers. Option B. Implement interventions to reduce the repetitive motions with awkward postures, as this has the highest risk score, and monitor the other tasks. Option C. Develop a comprehensive intervention plan that addresses the repetitive motions with awkward postures and the prolonged static postures, while also exploring ways to improve the physical exertion tasks to enhance comfort and long-term health. Option D. Focus solely on the tasks with moderate risk scores, implementing solutions that primarily aim to increase the speed of task completion. The correct answer is B. Implement interventions to reduce the repetitive motions with awkward postures, as this has the highest risk score, and monitor the other tasks. Explanation. This scenario presents a common challenge in ergonomics where identified risks, while not immediately catastrophic, have the potential to negatively impact multiple core ergonomics goals. The professional's task is to prioritize interventions based on a nuanced understanding of these goals and their regulatory underpinnings, rather than solely on the perceived severity of immediate harm. The challenge lies in balancing the immediate need for safety with the longer-term benefits of health, comfort, and productivity, all within the framework of applicable regulations. The correct approach involves a comprehensive strategy that addresses the identified risks by integrating improvements across all 4 ergonomics goals. This is justified by the overarching regulatory intent to foster a safe, healthy, and efficient work environment. Regulations such as those enforced by OSHA, Occupational Safety and Health Administration, in the U.S., for example, mandate employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm. This extends beyond immediate safety to encompass the prevention of musculoskeletal disorders, MSD, and the promotion of overall well-being, which are directly linked to health and comfort. Furthermore, a comfortable and healthy workforce is intrinsically linked to sustained productivity, aligning with the broader objectives of workplace efficiency and economic viability, often implicitly supported by regulatory frameworks aiming for a robust economy. An incorrect approach that focuses solely on the highest risk score, without considering the broader impact on health and comfort, would be professionally deficient. This fails to acknowledge that lower-risk items, if left unaddressed, can contribute to cumulative trauma and long-term health issues, thereby violating the spirit and letter of regulations aimed at preventing occupational illnesses and injuries. Another incorrect approach that prioritizes only productivity gains, neglecting the underlying safety and health concerns, is also unacceptable. This approach risks creating a facade of efficiency while sowing the seeds for future problems, potentially leading to increased absenteeism, higher workers' compensation claims, and ultimately, reduced productivity in the long run, contravening regulatory mandates for a safe and healthy work environment. Professional decision-making in such situations requires a systematic evaluation of risks against the established ergonomics goals. This involves understanding the interdependencies between safety, health, comfort, and productivity. Professionals should first identify all risks and their potential impact on each of these goals. Then, they should consult relevant regulatory standards and guidelines to understand the minimum requirements and best practices. Prioritization should then be based on a holistic assessment, considering not only the immediate risk level, but also the potential for cumulative effects, the likelihood of long-term health consequences, and the impact on employee well-being and sustained performance. This integrated approach ensures compliance with regulations and fosters a truly optimal work environment. Question 18. Research into the biomechanics of a manufacturing assembly line worker reveals that the employee frequently performs overhead-reaching tasks with their shoulder joint. The ergonomics professional needs to assess the potential for WMSD related to this activity. Which of the following approaches best aligns with U.S. regulatory frameworks and best practices for evaluating and mitigating risks associated with joint range of motion and stability in this scenario? Option A. Implement a mandatory stretching program for all assembly line workers to improve shoulder flexibility, assuming that increased range of motion will inherently reduce the risk of injury during overhead tasks. Option B. Conduct a detailed analysis of the employee's shoulder, joints' active and passive range of motion, assess the frequency and duration of overhead reaching, and evaluate the load being handled. Then recommend workstation modifications or task redesign to keep movements within a safe and comfortable range, minimizing static loading and awkward postures. Option C. Provide the employee with a general ergonomic awareness training session that covers common WMSD risk factors, including repetitive motions and awkward postures, without specifically assessing their individual joint capabilities or the task's specific demands. Option D. Focus solely on increasing the speed of the assembly line to improve overall production, with the expectation that faster work will lead to less time spent in any single awkward posture, regardless of the employee's individual joint limitations. The correct answer is B. Conduct a detailed analysis of the employee's shoulder, joints' active and passive range of motion, assess the frequency and duration of overhead reaching, and evaluate the load being handled. Then recommend workstation modifications or task redesign to keep movements within a safe and comfortable range, minimizing static loading and awkward postures. Explanation. This scenario is professionally challenging because it requires an ergonomics professional to balance the need for functional workplace design with the potential for musculoskeletal injury, specifically concerning joint health. The challenge lies in accurately assessing the range of motion, ROM, limitations of individuals, and translating those limitations into practical, compliant workplace adjustments without over-engineering solutions or compromising productivity. The professional must adhere to the principles of ergonomics as defined by relevant U.S. regulatory frameworks, such as those promulgated by OSHA, which emphasize hazard identification and control to prevent work-related musculoskeletal disorders, WMSD. The correct approach involves a comprehensive assessment that considers both the anatomical characteristics of joints and the specific demands of the tasks performed. This includes understanding the normal ROM for various joints and identifying deviations that may be indicative of a risk factor. The professional must then apply ergonomic principles to design or modify workstations and tasks to accommodate these limitations, ensuring that postures and movements fall within safe and comfortable ranges. This aligns with OSHA General Duty Clause, which requires employers to provide a workplace free from recognized hazards that are causing or are likely to cause death or serious physical harm, and specific standards related to ergonomics where applicable. Ethical considerations also mandate a proactive approach to employee well-being and injury prevention. An incorrect approach would be to solely rely on generic ergonomic guidelines without individual assessment. This fails to address the unique ROM limitations and stability concerns of specific employees, potentially leaving them exposed to WMSD. It also neglects the principle of individualization in ergonomic interventions, which is crucial for effective hazard control. Another incorrect approach would be to implement interventions based on subjective employee complaints without objective ergonomic evaluation. While employee feedback is valuable, it must be substantiated by an understanding of biomechanics and joint function to ensure that the interventions are appropriate and effective in mitigating identified risks. This approach risks misdiagnosing the root cause of discomfort or injury and may lead to ineffective or even detrimental modifications. A third incorrect approach would be to prioritize task efficiency over employee safety by forcing individuals to work beyond their safe ROM. This directly contravenes the ethical and regulatory imperative to prevent WMSD and demonstrates a disregard for the health and well-being of the workforce. Such an approach could lead to significant regulatory penalties and a breakdown in employee trust. The professional decision-making process for similar situations should involve a systematic approach. First, identify potential ergonomic risk factors related to joint stress and ROM. Second, conduct objective assessments of employee postures, movements, and task demands. Third, consider individual employee characteristics, including known or suspected ROM limitations and joint stability issues. Fourth, apply established ergonomic principles and regulatory requirements to design or recommend appropriate controls. And fifth, evaluate the effectiveness of implemented controls and make necessary adjustments. This iterative process ensures that interventions are evidence-based, compliant, and effective in promoting a safe and healthy work environment. Question 19. To address the challenge of a significant increase in reported musculoskeletal discomfort and errors in a manufacturing facility, which of the following approaches best aligns with the comprehensive principles of ergonomics and professional responsibility for a certified ergonomics professional? Option A. Propose changes to shift schedules and introduce team-based work structures to improve workflow efficiency and reduce individual workload pressure. Option B. Implement a comprehensive assessment that systematically evaluates physical stressors, cognitive demands, and organizational factors such as work pace, scheduling, and communication protocols. Option C. Conduct a detailed analysis of workstation layouts, tool design, and material handling processes to identify and mitigate physical risk factors. Option D. Develop a training program focused on stress management techniques and cognitive strategies to help employees cope with demanding tasks and high error rates. The correct answer is C. Conduct a detailed analysis of workstation layouts, tool design, and material handling processes to identify and mitigate physical risk factors. Explanation. This scenario presents a professional challenge because it requires an ergonomist to integrate multiple facets of ergonomics: physical, cognitive, and organizational, to effectively address a complex workplace issue. A superficial approach focusing on only one discipline risks overlooking critical contributing factors and implementing ineffective solutions. The challenge lies in discerning the most impactful and ethically sound approach within the regulatory framework of the Certified Ergonomics Professional (CEP) exam, which emphasizes a holistic and evidence-based methodology. The correct approach involves a comprehensive assessment that systematically evaluates physical stressors, cognitive demands, and organizational factors. This aligns with best practices in ergonomics, which advocate for a multidisciplinary perspective to understand the interplay between the worker, the task, and the environment. Specifically, this approach is justified by the CEP's commitment to evidence-based practice and the ethical imperative to protect worker well-being by addressing all potential sources of risk. By considering all three disciplines, the ergonomist ensures a thorough understanding of the root causes of the reported issues, leading to more sustainable and effective interventions. An approach that solely focuses on physical ergonomics, such as recommending new equipment without considering workflow or employee training, is incorrect because it fails to address potential cognitive overload or organizational inefficiencies that might be contributing to the problem. This narrow focus can lead to wasted resources and continued or new issues. Ethically, it falls short of the professional duty to conduct a complete and thorough assessment. An approach that prioritizes only cognitive ergonomics, such as implementing new software interfaces, without assessing the physical demands of the tasks or the organizational culture around workload management, is also incorrect. This overlooks significant physical risks and potential organizational stressors that can exacerbate cognitive strain. The regulatory framework for CEPs mandates a holistic view, and neglecting physical or organizational aspects violates this principle. An approach that exclusively targets organizational ergonomics, such as implementing new scheduling policies without evaluating the physical tasks performed or the cognitive load associated with those tasks, is similarly flawed. This approach ignores direct physical hazards and cognitive demands that are integral to the work system. A CEP's responsibility extends to all dimensions of the work environment that impact employee health and safety. The professional decision-making process for similar situations should involve a structured, systematic evaluation. First, clearly define the reported problem and its scope. Second, identify potential contributing factors across physical, cognitive, and organizational ergonomics. Third, gather data through observation, interviews, and objective measurements, ensuring a balanced collection of information from all relevant disciplines. Fourth, analyze the data to identify root causes and interdependencies between the ergonomic disciplines. Fifth, develop integrated solutions that address the identified root causes holistically. Finally, implement, evaluate, and refine interventions, always adhering to ethical principles and relevant professional standards. Question 20. Analysis of a warehouse environment reveals that workers frequently push and pull heavy carts across various floor surfaces. A certified ergonomics professional, CEP, is tasked with evaluating these tasks to mitigate the risk of musculoskeletal disorders. Which of the following approaches best aligns with regulatory requirements and professional best practices for assessing and addressing the force requirements and biomechanics of these pushing and pulling tasks? Option A. Recommend that workers simply use less force when pushing and pulling, relying on their own judgment to determine what feels manageable. Option B. Conduct a detailed biomechanical analysis of the pushing and pulling tasks, considering factors such as friction coefficients of different floor surfaces, handle heights, posture, and frequency of exertion, and compare the calculated forces against established jurisdictional limits and guidelines for manual handling. Option C. Advise the employer to purchase lighter carts, assuming this will automatically reduce the risk without further analysis of the forces involved. Option D. Suggest that the company adopt general ergonomic principles for manual handling that are commonly used in other industries, without specific verification against the applicable jurisdictional regulations. Correct answer is B. Conduct a detailed biomechanical analysis of the pushing and pulling tasks, considering factors such as friction coefficients of different floor surfaces, handle heights, posture, and frequency of exertion, and compare the calculated forces against established jurisdictional limits and guidelines for manual handling. Explanation: this scenario is professionally challenging because it requires the certified ergonomics professional CEP to move beyond simply identifying a risk to recommending a practical and compliant solution for pushing and pulling tasks. The core challenge lies in balancing biomechanical principles with regulatory requirements to ensure worker safety and health without imposing undue burdens. The CEP must consider the nuances of force application, posture, and frequency, all within the context of established guidelines. The correct approach involves a comprehensive evaluation that integrates biomechanical principles with specific regulatory requirements for manual handling. This approach is best practice because it directly addresses the identified risks by considering the forces involved, the postures adopted, and the frequency of the task, aligning with the intent of regulations designed to prevent musculoskeletal injuries. Specifically, it would involve referencing established ergonomic assessment tools and guidelines that are recognized within the relevant jurisdiction for evaluating pushing and pulling forces, ensuring that recommendations are not only biomechanically sound, but also legally defensible and practically implementable. This aligns with the ethical obligation of a CEP to protect worker health and safety by applying evidence-based practices and adhering to legal standards. An incorrect approach that focuses solely on reducing the weight of the object without considering the forces generated by friction or the mechanics of the push/pull action fails to address the biomechanical complexities. This could lead to recommendations that are ineffective or even create new hazards, violating the principle of providing competent advice. Another incorrect approach that relies on subjective worker feedback alone, without objective biomechanical assessment or regulatory reference, risks overlooking critical biomechanical stressors or failing to meet legal obligations for risk assessment. This approach is ethically problematic as it may not adequately protect workers from recognized hazards. A third incorrect approach that proposes a solution based on general industry best practices without verifying their applicability and compliance with the specific regulatory framework of the jurisdiction is also flawed. This could result in recommendations that are not legally compliant, exposing both the employer and the CEP to liability. Professionals should approach such situations by first understanding the specific regulatory framework governing manual handling and ergonomics in their jurisdiction. This involves identifying relevant standards, guidelines, and legal requirements. Subsequently, a thorough biomechanical assessment of the task, considering forces, postures, frequencies, and durations, should be conducted. The findings from this assessment should then be cross-referenced with the regulatory requirements to develop practical, effective, and compliant solutions. This systematic process ensures that recommendations are both scientifically sound and legally sound, fulfilling the CEP's professional responsibilities.